What is nuclear power plant? Nuclear fission is the source of nuclear electricity. Pressure steam is produced in nuclear power reactors by boiling water using heat during atomic fission. The steam is routed through the reactor steam system to spin large turbines blades that drive magnetic generators to produce electricity. Nuclear fission occurs when a neutron hits a larger atom, causing it to split into fission products, releasing significant energy. A nuclear reactor's core contains uranium or fuel formed into ceramic pellets. These energy-rich pellets, equivalent to 150 gallons of oil, are loaded into 12-foot fuel rods of plant operation. Boiling water nuclear reactors. In a boiling water reactor, the reactor core heats water, which turns directly into steam in the reactor vessel. The steam is used to power a turbine generator. Pressurized water nuclear reactors. In a pressurized water reactor, the reactor core heats water and keeps it under pressure to prevent the water from turning into steam. This hot radioactive water flows through tubes in the steam generator.
Proceed to the working principle. Nuclear power plants act similarly to thermal power plants, which differ in the energy source to boil the water to create a steam gas. The basic operation of nuclear power plant is by conducting a nuclear fission of uranium to produce a massive heat. 1 kg of uranium can produce as much energy as the burning 4,500 tons of variety high grade of coal or 2,000 tons of oil. Nuclear fission occurs when a neutron slams into a uranium atom, forcing it to excite and split into two small atoms, also known as fission products, and release additional neutrons. The additional neutrons released will repeat fission the other uranium atoms and initiate a chain reaction. When each atom splits, a tremendous amount of energy is released and producing a massive heat. The heat produced from the fission process is used to boil the water, which generates high pressure steam, then transferred to the turbine. In the turbine operation, the high pressure steam spins the turbine blades, which are connected to a rotor generator. As the turbine turns, the generator cuts through the lines of a magnetic field produced by electromagnets and induces a alternating current. This alternating current can be transmitted through power lines or converted to a more stable form using transformers for distribution. And lastly, cooling system. After passing through the turbine, the steam is cooled and condensed back into water using a separate cooling system. This condensed water is then returned to the reactor core to be heated again and completing the cycle.
What engaging in nuclear construction? A nuclear power plant uses enriched uranium for controlled fission reaction generating heat. This heat produces steam, powering a turbine connected to a generator for electricity. This is a nuclear power plant diagram. For the coolant process, it has a cooling tower and condenser. And to go for the nuclear reactor in the containment building, it has a control rod, pressure vessel, steam generator and core. And the steam go outside from the containment building, go to the turbine and power it the electric generator. There's two materials involved in nuclear power plant. The first one is uranium. The second one is plutonium. Uranium is naturally element found in the Earth's crust. It's the most common isotope of uranium are uranium-238 and uranium-235. Second one is plutonium. Plutonium-239 is another fissile material used in the nuclear power generation. There's the four power sources involved in this power plant. The first one is nuclear fission. Second one is heat generation, that's provide the steam. And the third one is steam turbine, that's provide steam to generate the generator. And the last one is electricity generation, is the generator provide the electricity for the consumer. There's a few requirements and consideration for a nuclear power plant. The first one is site selection. Second, cooling water sources. Number 3, regulatory approval. Number 4, waste management. Number 5, safety measure. Number 6, fuel supply and enrichment. Number 7, decommissioning plan. And the last one is emergency preparedness.
example of an actual site for a nuclear power plant. In the first place, we got Kashiwazaki Kariwa nuclear power plant from Japan, the world's largest nuclear power plant, with a net capacity of 7,965 megawatts. The first 5 units have a gross capacity of 1,100 megawatt, each varies. The 60th and the 70th units each have a capacity of 1,356 megawatt. Zaporizhzhia nuclear power plant, Ukraine. The Zaporizhzhia nuclear power plant has an installed net capacity of 5,700 megawatt and a gross capacity of 6,000 megawatt. It is currently the largest nuclear power station in Europe and the 50th largest in the world.